This lesson is on quadratic equations. Quadratic equations are equations with squares on the variables, such as ax squared plus bx plus c is 0. And this is called standard form, the way it's written here when it's equal to 0. A, b, and c are real numbers. A can't be 0 because then it would just be a regular linear equation. So there are many ways of solving quadratic equations, one of which, this is an example we're going to look at, is by graphing. You could indeed, when in standard form, look at the left side and graph it and see when is the answer to this equal to 0. Therefore, asking when does it cross the x-axis. So if we plot some of these points and we input x values and see what the answer is, our f of x, we'll see that our points will actually be of a parabola that has been shifted down 4. And you could plug in some points and check that for yourself. So for example, if you plug in 2, you should get 0. Is 2 squared minus 4 equals 0? Yes, it is. But also, negative 2 works because negative 2 squared minus 4 equals 0. Therefore, these solution points are actually 2 and negative 2, and those are the points that make it work. We can see that also just by guessing because this is a relatively simple example. There's no x term, and it's got small numbers. But let's continue. You could also factor this. And if you recall in our previous units, we always had everything equal to 0 and then we factored one side. So x squared minus 4 actually factors to be x minus 2, x plus 2 by the difference of squares. And then that leaves us with x is equal to 2 or negative 2, giving our solution set of 2 and negative 2 again. Now sometimes you can just use the square root property. So let's take that example, x squared minus 4 equals 0. We could solve for x squared on its own, and this is only because we have no x term. We just have the x squared term. So we could add 4 to both sides, and you'll see you get x squared equals 4. Now, what do we do when you have something squared equals a number? Well, every single time that we do this, we're going to get a positive and a negative option. As you can see here, in this simple example, you had 2 or negative 2. So when you square root both sides, you actually get a plus or minus there, always. So that's leaving us with x being plus or minus the root of 4. So we have this great option for solving when we have one thing squared and nothing else is of interest for solving. So, but this is a very nice cooked up case, isn't it? Because it's just so simple. But what happens when it gets more difficult and has that middle term? Well, we can use some of these ideas and continue. So if we can't factor, and if we can't make use of the square root property directly, we can actually do something called completing the square, which forces your equation to use the square root property. So let's take a look at this example here. First of all, I want you to recall this idea. If you have a bracket squared, remember when you open it up and multiply it all through, you're going to end up with a doubled middle term. That doubled middle term is going to help us discover the end term that we desire. So it'd be nice if we could get an equation squared equal to some number, because then we could just square root both sides and we'd have our square gone. And we'd potentially be able to solve for x. So that's the whole idea, is we want to force this equation to be this formula. But we have two terms here that we could put up with, but this last term, it doesn't follow this formula, and it also doesn't even factor. If you could factor, that'd be great. But what's the product? The product is -5, the sum is 2. So we can't factor this. But what if we still want to find an answer? So let's take a look at completing the square. First of all, you want to get your x terms alone because they're going to be this part. And we're going to want to add this last term to both sides so that it fits back into this nice little package. So let's add the 5 to both sides and just get it out of the way so you can see x squared plus 2x is equal to 5. Now we're missing a term that we can add to both sides, and what would that term be so that it follows the perfect square trinomial formula? Well, think about this nice case here. We've got a nice x squared by itself, and then a 2, and then an x. So what is our b? Well, b must be 1. So you'll see this is the coefficient here. So if we want to just get b by itself, we'd want to take 2b and divide it by 2. Then we'd have b, and then we'd square it, and that would be our last term. So let's do that. Let's take 2, divide it by 2. Well, that's just a 1. You can see b is a 1 here. And you square it, 1 squared. Well, that's just a 1. So I actually just want a 1 here. So now, this is actually my desired perfect square trinomial formula, and it is x plus 1 squared, and this side equals to 6. Now that is the essence of completing the square. You're essentially completing this formula so that you have it on one side and it ends up being in a nice squared package. Now we can apply the square root principle and root both sides, leaving plus or minus root 6 equal to x plus 1. Root 6 doesn't simplify, but that's okay. We can subtract 1 from both sides, and we end up with x being equal to -1 plus or minus root 6. Now you could leave this answer. You could also simplify and find the approximate numbers by typing in -1 plus root 6 on your calculator and then -1 minus root 6 and getting the decimal equivalents. But what if it's not so perfect? Here we've got a leading coefficient of 2. Well, in the previous case we didn't have a 2 there, right? We had a nice 1 here. It was so nice and simple. So we always want this to be a 1. So how do we make it a 1? Well, let's just divide everything by 2, the leading coefficient, and that way we're clear. But we have to deal with some fractions. But that's all right. So we've got our key part, and we want to fill in our last term. Now this last term doesn't quite work for us, so let's move it over, and we've got x squared plus 3/2 x equals a half. And we want to fill in this term here so that it becomes the perfect square trinomial formula. So remember, we take half of 3/2, whatever this number is. So how do you take half of 3/2? Well, we multiply by a half, and then we're going to square it, and then we're going to add it to both sides. So remember, this extra term that we want to put in is going to be half the x coefficient and then squared. That's what's always going here on both sides to fill in our formula. So when you do that, you get 3/4 squared, and when you take 3/4 squared, you get 9/16. Now, because I did that to this side, I also have to do it to this side. But this now boils down to a nice package of x plus, and remember this sign determines this sign, 3/4. Now we want to add these fractions together. We need a common denominator of 16, so multiply this one by 8. You have 8/16 plus 9/16 is 17/16. And now we can continue and square root both sides. Square root of both sides with a plus or minus. X plus 3/4 is equal to plus or minus the square root of 17 over the square root of 16. You'll notice I split the square root so I can hopefully simplify at least one of them, and luckily root 16 simplifies to be a 4. So we've got x plus 3/4 equals plus or minus root 17 over 4. And we want to subtract our 3/4 from both sides, giving us negative 3/4 plus or minus root 17 over 4. We can write that under one common denominator, leaving us with the following solutions. You could type in both cases of negative 3 plus root 17 all over 4. Don't forget to put all the brackets in properly in your calculator. Or you could have negative 3 minus root 17 all over 4. So what happens in general? Now, if we generalize using a, b, and c as our coefficients, we can lead to a very important formula which allows us to then find the answers for x for any quadratic. First, we need to divide everything by the leading coefficient. Divide by a. So now you've got x squared plus b over a x plus c over a equals 0. Remember, we moved this term over. We had x squared plus b over a x equals negative c over a. Then, remember, we took half of the middle term, so that's b over 2a, squared it, and added it to both sides. So that's adding b squared over 4a squared to both sides. Now this becomes one nice package of x plus b over 2a squared. Notice if b was actually a negative here, then that would affect this to be negative. Equals, and we need to combine the common denominators and add these fractions. So we need times this one by 4 and this one by a. So you've got negative 4, and I'm going to write this instead of CA as AC just so it's in alphabetical order, over 4a squared plus b squared over 4a squared. Now they're common denominators. So I'm just going to rewrite this over here so we have more room. So that's x plus b over 2a squared is equal to negative 4ac plus b squared over 4a squared. Now, if we take the square root of both sides, we need a plus or minus here, then we get x plus b over 2a is equal to plus or minus, and I'm going to split this root, and I'm also going to rewrite so that the b squared is first just because it doesn't have a negative on it, all over the square root of 4a squared. But the square root of 4a squared happens to be the same as 2a, so let's rewrite that. And then we can subtract b over 2a from both sides, and we're left with, you'll see that there's a common denominator, so if you subtract b over 2a plus or minus the square root of b squared minus 4ac, you actually get the formula for finding x, no matter what. this formula also has something very special. So here's the quadratic formula. And what's very, very special about it is that the inside of the root is called the discriminant. Do you remember in the past example where you had this root 6, for example, left over? Well, in your quadratic formula, if you can find b squared minus 4ac, that's the part under the root. So if this is negative, you know there's no solution for sure. If this ends up being equal to 0, then you know that it's going to be one answer because there's going to be no plus or minus anything. If it's a nice positive number that is a perfect square, then it actually simplifies, and it probably means that you could have factored it. And if it's a positive number and it's not a perfect square, then you know that it's going to be left as a root, a simplified root. So let's take a look at applying the quadratic formula. So say you had to solve an equation like this. Well, first we need to get it into standard form. So that's negative 2t squared minus 4t, and then let's add the 3 to both sides. So we've got our a, b, and c. So you could keep these as negative, you could multiply everything by negative. Let's just keep them as they are. So our a is negative 2, b is negative 4, c is 3. And we can now use this formula, which we developed from completing the square, and find the solutions. Notice you could find the discriminant. What is the discriminant? Try to find it. Well, this will be 16 plus 24, which will be 30. So this tells us that the root's going to stay and it's not a perfect square. So this is 4 plus or minus 16 plus 24 over 4, which gives us 4 plus or minus the square root of 40 over 4. Now we can see if we can simplify this root. 40 was 2 times 20, which was 2 times 10, which is 2 times 5. So you get 2 root 10 over 4. You could factor out the 2, which is then 2 plus or minus root 10 over 4, and simplify the factors, leaving you with 2 plus or minus root 10 over 2. Now you could also answer this in terms of the decimal equivalents of the two answers that this produces. So using the quadratic formula, knowing that this inside of the root is the discriminant, let's just go back to thinking about which one of these examples can be solved by factoring, right? You could think about the product and the sum, but you could also take the discriminant. So for this one, the discriminant, this is a, this is b, this is c. So b squared minus 4ac, which is under the root, will be 8 squared minus 4 times 5 times 3. So if you do that, you get 64 minus 60, which is 4. So what does that tell us? Well, when you take a root of 4, it's a perfect square, it's going to be a nice number. So that's going to mean that, yes, this is factorable. You could take this example here. b squared minus 4 times a times c, you get 1 minus 4 is negative 3. Yikes, you can't take a root of a negative. This one's going to have no solution. Don't even have to do everything, you just need to check what's in the root. Now this one will have 2 squared minus 4 times 2 times negative 3. And that's going to be 4 plus 8 times 3, which is 24, which is 28. Can we take a root of 28? Yes, we can, but it's not going to be a perfect square. So no, you can't solve by factoring. You need to use the quadratic formula or the completing the square method. And finally, you could check this one. And that would be negative 28 squared minus 4 times 4 times 49. And you can see that this is equal to 0. So what does that tell you? Well, if you add plus or minus to 0, that would mean there's only one solution. So yes, you can solve by factoring, and you can actually see that this is a perfect square trinomial. Doesn't it factor to 2x plus 7 squared equals 0? So the answer is actually negative 7/2. So there's some food for thought.